Hello, and thank you for joining me again. We're going to be looking at the problem that we want to find the surface area of the object retained by revolving the function f of x equals 1/14 e to the 7x plus e to the negative 7x around the x-axis on the interval negative 2 to 2. So we're going to draw that graph, find what that looks like three-dimensionally, and then we're going to find our surface areas. Alright, so now I've plotted f of x on the interval negative 2 to 2, and it looks roughly like this. Notice I didn't label the y-axis because this gets really big really quick, but the idea is just that, okay, well, if we're going over this interval, we're going to have this general shape, and that's going to be good enough for our purposes here. Now what we're going to do is we're going to take this function and revolve it over the x-axis. So we're going to pick this up and rotate it around. And if we do that, we're going to get something that's going to end up looking like this. And because we're revolving it around, we're going to get circular shapes like this. And then like, say this. So what we get here is something that kind of comes into a small section and then gets bigger as we move out. We have it circular all the way around. We can kind of imagine what that's going to look like. And so hopefully you can visualize that. Now that we have that, what we have to do is we have to find our cross sections so we can add them up to find the total surface area. So in order to cut cross sections for area, what we're going to do is, well, we're actually going to cut cross sections that look something like this. And so what we're doing is we're cutting out a piece of this so that it moves. It has, these are circular, they're coming out from the edges here, and then it's going to move along the top of the function, or the surface, top of the surface that I have written out using my function by revolving it around the x-axis. Now in order to find the area of that cross section, because again we're looking for surface area, what we have to do is we have to kind of look at this as a new shape. And so what I'm going to do is the trick I had before is I'm going to cut this at this piece, I'm going to pull it and stretch it out, and what I'm going to get is something that looks like this. Not exactly to scale, but the idea is that I've pulled this out and I've ended up with what looks like a rectangle. Now the idea is that this length will be slightly bigger than this length, but they will be close enough that we can get a good approximation by considering them the same. But this length we're going to have to find as well, and so what I want to start off with is just what is this length. So is this, if this is my given x value, what I get is that that length is the total length around, or that is the circumference of the circle given at my value x. So what we would get here is that the length here is going to be 2 pi times my radius at the given x. Now the width of this, we're going to be tempted to say is going to be delta x. However, it's moving a little bit too much because it's moving in both the x and y direction, so delta x isn't going to be a good enough approximation. So we'll have to use the same trick we had last time, is that we're moving in the x and y direction. So the actual length is going to be the change of the change in x squared plus the change in y squared, take the square root like we had with arc length. So what we get is this is the square root of delta x squared plus delta y squared. So again, we can simplify that like we did before, and we get 1 plus delta y over delta x squared times delta x. So that if we want to find the total area of that cross section, we're going to get 2 pi times the radius times the square root of 1 plus delta y over delta x squared times delta x. So I ran out of room at the end there. Alright, so now in order to find the total volume, I'm going to have to add these all up. So I'm actually going to find r, and I'm going to find delta y, delta x in terms of y. But first I'm going to say that the total area is the integral from a to b of 2 pi r, the square root of 1 plus dy dx squared, because I'm letting these get infinitesimally small, times dx. So now to find r, notice that r is, for this x value, is the corresponding y value for this function. So what we get is the y is equal to the 1/14 e to the 7x plus e to the negative 7x. So what we're going to get here is the integral of 2 pi times r is 1 over 14 e to the 7x plus e to the negative 7x times the square root of, and then I'm going to have to find dy dx, so I'm going to have to take the derivative of this. So the derivative of that is going to be, I can factor out the 1/14th, and then I can say the derivative of e to the 7x is a chain rule. Derivative of the outside is e to the I is e to the I. Derivative of the inside, derivative of 7x is 7, so I get 7e to the 7x. And the derivative of e to the negative 7x, following the same process, is negative 7e to the negative 7x. And then I'm going to have to integrate with respect to x. And I'll put that down there since I have run out of room. Now, we still have to find a and b. So what is the smallest x value I'm interested in? Well, that's actually given to me in the problem, so it says start at -2 and go to +2. So I'm actually going to integrate from -2 to 2 of 2 pi times 1/14th e to the 7x plus e to the negative 7x times the square root of 1 plus the derivative is 1/14th 7e to the 7x minus 7e to the negative 7x, and this derivative should be squared. Again, pulling the squared down from here, and then I'm integrating with respect to x. If you would like to see how to do that, again, check the written up version that I have provided a link to down below, but I'm going to leave it here because we have set up this integral in order to find the surface area, and so now all that's left to do is to evaluate the definite integral. Alright, thank you for joining me for calculus practice. If you'd like to see more problems, you can check out the rest of this playlist available up here. Also, please sure to subscribe to the channel so you can see when we have more of these coming up. In addition to that, you can also check out the link available in the description below to see the written version of each of these problems so that you can pull that up to follow along with the video or to do on your own for extra practice. Thank you and good luck with your studying.